Hello my dear children. I hope you all are doing very well. So, we have come up with a new video for revision. So today we are going to revise the different models of an atom which we have revised during online session. But before going further, let me remind you one more time, don't forget to like my video, and if you have not subscribed my channel, you have to. So let's start revising our topics with the help of the upcoming videos.
Thompson's model of an atom. After the discovery of electrons and protons and discovery of natural spontaneous radioactivity in 1896, Sir J.J. Thomson proposed the first model of an atom in 1898. This model is known as J.J. Thomson's model or the plum pudding model of an atom. Funny name. He proposed that an atom has a spherical shape of radius approximately 10 raised to minus 10 meters, in which the positive charge is uniformly distributed. The electrons are embedded into it uniformly so as to give the most stable electrostatic arrangement. In this model, the atom is visualized as a pudding or cake of positive charge with raisins, that is electrons, embedded into it. This model is also called raisin pudding model or watermelon model. These guys sure love their food. Well, the mass of atom is assumed to be uniformly distributed over the atom. This model was able to explain the overall neutrality of the atom but failed to explain origin of atomic spectrum and alpha particle scattering experiment. Rutherfords Experiment. Rutherford, in an attempt to verify various models of atom proposed by Dalton and Thomson, he carried out alpha particle scattering experiments in 1909. Radioactive source of alpha particle was placed in the cavity of lead block. The alpha particles emitted from this source were passed through lead slit system to give a fine beam of alpha particles. This beam of alpha particles was bombarded on a thin gold foil of thickness 100. The gold foil was surrounded by fluorescent screen of zinc sulfide. Whenever alpha particles would strike the screen, a tiny flash of light was produced at that point. Rutherford observed that most of the alpha particles passed through the gold foil without deflection. Some of the alpha particles were deflected through a small angle less than 90 degrees. A very few number of alpha particles were deflected by a large angle greater than 90 degrees. And a very few, that is 1 alpha particle out of 12,000 alpha particles, was deflected through an angle of 180 degrees, that is, it rebounded. Now, chemists love to think, research, and think a little bit more. So he observed, and depending upon the observations, Rutherford drew the following conclusions. First, the atom consists of large empty spaces, that is, they are extremely hollow. Second, the positively charged alpha particles get repelled and deflected by the positive charges in the atom. Rutherford called this positively charged space of an atom as nucleus. Third, the volume occupied by the nucleus is negligibly small as compared to the total volume of the atom. The radius of the atom is about 10 raised to minus 10 meters, called as angstrom unit. and that of nucleus is 10 raised to minus 15 meters, called as Fermi unit.
Bohr's model of an atom. In this module, you will learn about the Bohr's model of an atom. Prior to Bohr, there were a number of scientists who were working on the structure of atom. Rutherford was one of them, and his model was the closest model to the Bohr model of atom. In fact, Niels Bohr had helped to overcome the problem in the Rutherfords model of an atom. The Rutherfords model of an atom had a major drawback, that it could not explain the stability. It showed that electrons in an atom revolve around a positively charged center called nucleus. However, later on, it was found that any particle in a circular motion would undergo acceleration and thus would lose energy. So, the electron would take a spiral path and would finally fall into the nucleus, and the atom would collapse. But this does not take place in reality. Bohr said that electrons do revolve around the nucleus, but their energy remains fixed. He explained that the energy of electrons remains fixed because they are restricted to some fixed orbits. Each of these orbits is at a fixed distance from the nucleus and is associated with a fixed amount of energy. These orbits with fixed energy are known as discrete orbits or energy levels. These energy levels are represented by the letters K, L, M, N or the numbers 1, 2, 3, 4 starting from the center. So, the final model of Niels Bohr was similar to the Rutherford's model of an atom, which states that an atom consists of a positively charged center around which the electrons revolve. The only difference was that in the Bohr model, electrons revolve around a nucleus in fixed orbits with fixed energy. For his work on structure of atom, he got a Nobel Prize in 1922. Let's recap. Bohr model of atom suggested that an atom consists of a positively charged nucleus and electrons revolve around it in special orbits called discrete orbits or energy levels. The energy of these discrete orbits remains fixed. These energy levels are represented by 1, 2, 3, 4 or KLMN starting from the center. Bohr got the Nobel Prize for his work in 1922.
I hope you all have understood all the models of an atom very well. So start preparing yourself for your final exams. Thank you so much everyone.